All right, for problem number 5, it says a photography club tracks the number of photos of its members, or that its members have published in the school paper over the course of 1 year. The total number of photos published can be represented by the expression 2m squared minus 5. The table lists the total number of photos published. So now, we got to finish the table. So we're saying this right here is our rule, 2m minus 5, where this represents the m's.
2m squared minus 5.
2m squared, thank you. And this is the number of photos. So we could think of it like, we could think of it like p equals 2m squared minus 5, right? Like an equation. Think of it like this. It's like y equals 2x squared minus 5. But we're using different letters. Where m is the months and p is the photos published. So they're assuming that you're going to publish a certain total number of photos per month or something along those lines. So now what I'm going to do is I'm going to plug this 4 in to get this answer. So I'm going to say 2 times 4, wherever there's an m, I'm going to plug in a 4, and then I'm going to subtract 5. So what I'm doing is I'm using this equation, but I'm plugging in 4, my input value, right?
Yeah.
So what's 4 squared?
16.
What's 16 times 2?
No, 6.
32. What's 32 minus 5?
27.
Okay, so we got 27. Now look, to get from 3 to 13, what did we do? We added 10. Now to get from 13 to 27, what did we do? 14. All right. Now that's not a constant rate of change for y, is it?
No.
So is this a linear function?
No.
No. Okay, so good to keep in mind. Let's do the next one. I'm going to say 2 times the next quantity squared minus 5. So we're going to choose 5. What's 5 squared?
25.
Times 2 minus 5. 45. Now, to get from 27 to 45, what do you think we did?
Add 20.
I think it's 18.
No,
I think it's 18. So to get from there to there, we added 18. Hey, do you start to see a pattern? Yeah, we're adding 4 to what we're adding each time. So what do you think we'll add the next time?
22.
22. So what is 22 plus 45? 67. So our answer should be 67. Let's check. 2 times 6
12.
squared minus 5. So what's 6 squared? 36. Now this one might be a little harder. What's 36 times 2?
Oh, 72.
72. So let's just write that out over here on the side. If I say 36 times 2, right? 2 times 6 is 12. Carry the 1. What's 2 times 3?
6.
Plus the 1 is 72. So you guys are right, 72. So I got 72 minus 5. What's that? It is 67. So man, you guys are smart. Now, okay, that's good. What is our delta x here to go from 4 to 5?
1.
What is it to go from 5 to 6?
1.
So what can we assume about this number?
3.
It's 3, right? We minus 1. What's this one?
2.
Now, could I verify those results?
Yeah.
Yeah.
How?
Well,
3
Applying them. Plugging them in.
times 2 minus 5.
Okay, yeah, what were you going to say? I think what you guys said was right, but I want to hear what you
yeah, right, but I was going to say, when you look at the expression they gave you, it starts at 2, right? So you would start at, like they say 2m, so it would start at 2m, basically. They don't give you an option to put 1, you just put 4, 5, 6, which you say is 3, 4, 5, 6. Right?
Right. Well, we don't know for sure. Right? So there's nothing. She's saying, look, the table only goes to 2 months. So we can assume that it's right. But then, as she was saying it, I was thinking to myself, well, when you read the the heading, it doesn't say when they started it, right? When they started collecting the data. And then what you guys said, he said apply it, and then she said plug it in, which I think they're saying the same thing. So if, in other words, if I pick 2, and I say 2 times the quantity 2 squared minus 5, what's 2 squared? 4 times 2 is 8. 8 minus 5 is 3. So that worked. So now we're going to plot those points, right? So if I look at, I've got a bunch of scribbles here, but we have the following points. We have 2 comma 3, right? 2 comma 3. So if I go over 2 and 3, it's about right there. If I go to the next one, which is 3 comma 13, 3 to 13 is probably about right here, right? If I go 4 comma 27, I go over 4 and I go up 27, that's probably about right here, right?
Yeah.
Then we've got 5 comma 45, so I go over 5. Maybe I should label these. So we've got 2 comma 3. This next one is 3 comma 13. The next one is 4 comma 5, or I mean 27. And then the next one after that is 5 comma 45. So I'm going to go 5 up to 45, which is about right here. 5 comma 45. And then the next one is 667. So I'm going to go over 1 and go up to 67, which is about right here. And so I have this little curve that kind of looks like this.
We have to plot all of them.
Yes.
Yeah. So the question was, do we have to plot all of them? And my answer is yes. and what is the y-intercept for this bad boy? -5, right?
Yeah.
So now that -5, since they're counting by 4s on the y-axis, would be about right here. So that makes sense, right?
Yeah.
So I kind of do one of these deals. Any questions on that one?
No.
How did you know that the y-intercept was -5?
Oh, because when does, okay, so I think I know what he's saying. That b, you know, y equals mx plus b, the y-intercept is b.
Yeah.
But that's true for any polynomial. And here's why. This has a variable m. But
yeah.
remember, the y-intercept occurs at when x equals 0, and then we have some y value.
Oh, so the y value is the value that's being subtracted.
Yeah, so look at this, though. If I plug in 0, what's 0 squared?
0.
Times 2,
0.
0. So I'm left with the positive, or the -5. Why are we always going to be left with that constant that's by itself off at the end?
Because everything else is 0.
X is at 0.
Everything else has the variable, and if you multiply it by 0, then you're going to get 0. So if you have any polynomial that has a constant at the end, that's usually the y-intercept. Okay? And that's why. Okay, good. Any questions?